Good afternoon and welcome to today's EHS Today webcast, Risk Assessments, Keeping Your Employees Safe and Your Machinery Compliant. I'm Stephanie Valentic, Associate Editor for EHS Today, and in a moment I'll be turning things over to our speaker. I would just like to begin by thanking PILS for sponsoring this afternoon's webcast. I would like to remind all of you that if any time you experience audio difficulties or advancing of the slides, simply press your F5 key to refresh your webinar console. I would also like to encourage all of you to ask our speaker questions. As a question occurs to you, simply type it into the Q&A box on the left-hand side of your screen, and we will address as many of your questions at the end of our presentation as we can. Now let me introduce today's speaker. Dr. Doug Sten has over 25 years in the plastics machinery industry, employed as a consultant, a global product safety manager for an OEM, and a corporate safety director for a plastics container manufacturer. He has over 20 years participating on U.S. and international safety standards committees. For more information about Doug, click on the speaker widget on your console toolbar. With that, Doug, the floor is yours.
Thank you. Good afternoon, everyone. Let's get started. Hopefully what you will learn today, whether you are new into the safety field or a seasoned safety professional, here are some of the things that we will cover today, and hopefully you'll be able to take back to your particular employer and put into process, is how to recognize and define hazards and risks, how to prepare a risk assessment, understand the steps involved in a risk assessment, eliminate or reduce the risk exposure, know when you reach an acceptable level of risk, and verify risk reduction applications. What is a hazard? I'm trying to keep everything in perspective and trying to keep everything on a simple level of understanding. The hazard is a condition that has the potential to cause injury or equipment damage, and sometimes equipment damage can cause injury. Examples of hazards: we have drawing in or trapping hazards. These are more common types of hazards that you're probably more familiar with. Belt and pulleys, chain and cog. And we have entanglement hazards, rotating shafts. I've seen a lot of these in industry, general industry and construction, that can cause people to get entangled, whether they're the end shaft or the center shaft on drive motors. On the right, you have turret lathes that are not particularly fully guarded, that can caught in clothing, gloves, hair, rags. Then we have impact hazards, and probably most of you have some type of equipment similar to the ones you see in the photograph. You've got robotics, whether those are in your palletizers, could be in some welding operations, some laser type operations, and to the right, most of us from the standpoint in our warehousing is the stretch wrappers, where we have the potential for being impacted by the moving wrapper arm. We have crushing hazards, things in which our body can be caught in between, whether hands, fingers, or full body. To the left is an example of an injection molding machine. To the right is basically a leak detector for bottles which turn on a star key, which exposed could get you crushed in between the side of the machine and the star mechanism. Now, what is the risk? Again, to keep it in simple terms, risk. It's a level or degree of exposure to the hazard. Assessing the frequency of that exposure, the probability of being hurt or injured, and if that case occurs, what would be the severity of that injury, or what would that damage be? We have risk in everything that we do. At our home, in the place of work, traveling, whether by plane or by car, whether on business or in pleasure. What about this task? How dangerous is this task? How can one be injured? How severe would the injury be if this person happened to fall over the handrail on the scissor lift? Safety engineering approach, the hazard management process. And we're going to go through these. Hazard identification, that's the first thing. We've got to be able to identify what the hazards are. Risk assessment, risk control, design the control, and then trial and implementation of the controls. Do they work the way we anticipate them to do? Safety engineering versus behavior aspects. Hazard management process. Now, we've talked about the hazards. Now we're getting into the controls. The engineering application. Elimination, substitution, engineering, administration, and then basically the administration and the PPE is more into the human behavior aspects. So let's take a look at these. We talk about elimination. Completely remove or eliminate the hazard. We have no hazard. Do we have a risk or do we have a danger? Obviously, no. No hazard, no risk, no danger. But in most cases, there's going to probably be a certain level of exposure to a hazard, and that's what we need to look at is the overall exposure to that hazard. Substitution. Substituting, replacing a hazardous condition or work process with a non-hazardous one. Engineering. If a hazard cannot be eliminated or replaced, the next measure is to reduce that risk of exposure to an acceptable level. Guarding of the machinery, and we'll talk about interlocks, and we'll talk about fixed guards. Using enclosures, fully enclosures around a particular piece of equipment. Automation and applied ergonomics. One thing I want to stress dealing with the engineering that is extremely important that I've seen and experienced working as a OEM and as an end user, it is very important to apply your ergonomics to the type, size of the guarding system that you are designing for that particular machine. You must take in ergonomics as it plays a huge part in the maintaining the efficiency and the effectiveness of your guarding system. When we move down the hierarchy of control is administration. This comes into the area of behavior safety. We have training of the employees. We develop SOPs and work instructions. We try to reduce the number of employees that are exposed. The more people exposed, the higher the probability that someone's going to get hurt. Reduce the period of exposure. The longer you're exposed to that hazard, the higher the probability of someone being hurt. Develop and implement lotto procedures of fixed, applicable, compliant safety signs. Keeping in mind that safety signs are awareness devices. They do not make you put guards back in place. All they are is a reminder of a hazard and what you need to do to prevent that exposure or reduce that exposure to that hazard and make sure it's in place. PPE. Again, this is the final step in the hierarchy of control. This is the step, is your last basic control where other engineering controls are not feasible. You have safety glasses, gloves, hearing protection, safety shoes. Similar from the standpoint that if you have an interlock door on an oven, if I open up an interlock door and the oven is 300 degrees, you're not going to reduce the temperature down to 140 degrees by opening up an interlock guard. You have thermal conditions you have to deal with. So in that particular sense, you need to make sure you have the proper PPE. What is a risk assessment? It's a systematic method Measure the risk of exposure to an identified hazard or hazards in an effort to eliminate or reduce it to an acceptable level. Talk about acceptable risk, risk reduction, mandates, methodologies, risk assessment reports, and examples. Let's see what we got. Where we start, we got to determine the limits of the machine, identify the hazards, risk estimation, risk evaluation. Is the machine safe? Got a yes, we're done. No, we need to get into some risk reduction measures to get us to that acceptable level. All right. Determine the limits on the machine. Define the limits on the machine. What does this involve? What is the purpose of that machine? What are the energy sources? We've got to identify electrical, pneumatic, steam, gravity, springs, mechanical. These are all the energy sources that can hurt or cause damage. What type of process will be performed? These are questions you have to answer up front in the process. Next is hazard identification. We talked a little bit about that before. We've got to be able to identify the hazards at the next level in order to continue with the process of risk identification, risk assessment, and risk reduction. Form a task analysis. Important is a task analysis to include the operations, servicing, cleaning, setup, inspections, troubleshooting, and maintenance and service. This is extremely important because this gives you an idea as to not only what that task is, but how often is it being performed and how often are they in that particular area exposed to those particular hazards. As I mentioned in the next is frequency and duration of exposure to the hazard. Very, very important when going through your risk assessment in your hazard identification. Risk estimation. Risk related to the considered hazard is a function of the severity of the possible harm and can result being exposed to that hazard. And the probability of occurrence. How easy is it to get to that hazard? How difficult is it to get to that hazard? These are very important factors in your determination in your risk assessment. Risk evaluation. Is the current level of risk acceptable? Yes or no? Are the safeguards compliant with safety standard requirements? Now, if you look at, OSHA says that you can't get over, around, under, or through an opening or an area to get hurt. So basically, looking at the standards, looking at your machine, standing on the floor, can you get into that hazardous condition while the machine's running and get hurt? So very simple. Can I get over it standing on the floor? Can I reach around? Can I reach under? Can I reach through the opening, get myself hurt? Is the cost of reducing the risk practical? This is something from the standpoint of what is cost benefit versus what's cost beneficial. So again, you need to look at from the standpoint that the cost may be prohibitive and then work your way down through the engineering controls and may have to end up with PPE. The PPE, as I mentioned earlier, is your last resort in addressing the hazards and the risk exposures. Okay, risk reduction. Okay, we've determined that we've got to the risk evaluation. Is the machine safe? And we're saying no. So what we got to do is we've got to go through and determine and select the appropriate risk reduction measures. To determine and require the degree of risk reduction. What do we need? How much do we need? And consider a combination of measures to reduce the risk. Determine the required safety circuit integrity for that control. And we can talk about different levels like Category B through Category 4, performance levels, basically A through E. Ensure that these measures are seamlessly integrated into the operation of the machine and not simply just add-ons and cause issues with operators and maintenance personnel. Risk reduction requirements. What is necessary risk reduction? How effective do my risk reduction measures need to be? How I eliminate the hazard? Do I use fixed guards versus interlock doors? Is a light curtain needed? And what is the proper safe distance that my light curtain will react and stop the machine before I can reach it, whether full body or with my hands and fingers? Approaches to design safety. We've got 2 steps. 1, reduce risk by inherently safe design measures. Step 2 is risk reduction by safeguarding and implementation of complementary protective devices. Let's see what we're talking about. Step 1, risk reduction by inherently safe design measures. 1 is protective measures which either eliminate the hazard or reduce the risk associated with the hazards by changing the design or operations. Characteristics of machines without the use of guards or protection devices. How do we do that? We either slow the movement or reduce pressure in the movement, so maybe that the worst case severity would be a bruise or a minor cut. This is just an example of risk reduction by inherently designed equipment. The end roller of the idle, it sits in the open slot that allows it to pop out. Someone's hand gets drawn in by the previous roller. Risk reduction by safeguarding. We got 2 different types of physical safeguards. We got movable guards with interlock. Normally, and there's no fast and set rule, but normally movable guards with interlocks are for point of operation. People have to get in to that particular point of operation safely, but on a high frequency, routinely, whether that's taking out a jam, making a minor adjustment, or particularly in the food industry is wet cleaning of equipment. So again, in relationship to the next item is the fixed guards. This is generally set aside and designed for power transmission, belts and pulleys, chain and cog, rotating shafts. Normally, those guards are not removed with a frequency of less than 6 months. Check the belts, check the chains. So again, the longer time of intervals and power transmission, you want to reserve that for fixed guards. Engineering design applications considerations. I want to look at operator compatibility. Well, what do you mean by that? Well, it's easy to operate, it's easy to service, it's easy to maintain, troubleshoot, and to set up. Well, that's fine. But on the other hand, it's a two-way street. I have to make it reasonably safe to perform the above. As a safety professional, looking at a design, I could throw a net over a piece of equipment and say, I've done my job. But then I have the maintenance people, I have the operator coming to me and asking me, how am I going to run this machine? So when you look at the process, look at the machine, safety, operations, maintenance, engineering, all has to be on the same level, given the same attention. So everything is across the board. Once you make it too overly protected, there's when you find people to start circumventing and bypassing safety systems. So everything should be on the same plane. Everything is working together, again, on the same plane. Safety is important. So is finding a way to maintain that reasonable safeness and still allow operators and maintenance, quality, and engineering to do their job also. Okay. Risk reduction by safeguarding. We've got presence sensing devices, light curtains, safety mats. I think probably you've all seen these and are probably using these within your facilities. Risk reduction by safeguarding, two-hand controls, enabling switches, hold-to-run functions. I want to point out one thing just to make a comment on two-hand controls. What you see in the picture, normally you will not see maybe in your plant or your experiences. Normally you'll see the two-hand palm buttons sitting on top of the plate with protective rings around those. What happens with that is that they do not want a person to bypass or hold down the two-hand controls with one hand and put their hand into the point of operation. This is a better aspect from the standpoint that I can actually use the palms of my hand to actuate it, and I've reduced two motions in my wrist from an ergonomic standpoint. So this is just a good example of a good safeguarding system but integrating good ergonomic applications. Okay, risk reduction by safeguarding. Emergency stops. These are what we call complementary devices. They are not what we call protective devices. They're complementary. What I mean by that, a fixed guard or interlock door keeps me out of the hazard so I can't get hurt. These stops, what they do is they reduce the exposure to an event that has already occurred. Standing next to a conveyor and I get my sleeve caught in the belt, I hit the E-stop. The event has already occurred. The E-stop hopefully is reducing that severity of injury, again, after an event has already occurred. So again, these are complementary, not primary safety controls. Okay, risk assessment tools to be successful. Seems like everybody likes to have acronyms, alphabet soup. So the track put it together several years ago when we were designing machines going into Europe in the 90s. We called it the Technical Risk Assessment Committee, called it TRACK. Everybody likes something short. And in addition to that, in being your risk assessments, you have to do your research. You have to inspect. You have to observe. You have to interview. You have to review documentation. Then you have to estimate the risk. Let's break this down a little bit. Technical Risk Committee. You need to train and involve all the stakeholders. Work with that specific machine to assess. Engineering, maintenance, operation, quality, safety, basically as the facilitator. Make sure everybody is getting their point of view across, and sanitation and cleaning. Extremely important. You get buy-in, and normally from the standpoint that once you get your safeguards in place, everybody should be using those particular safeguards, and there should be very little or no bypass and interlocking systems. Everybody has a different perspective in their function of what they need to do, not only to do their job, but also how I can keep myself safe and not get hurt. Research. Identify the applicable safety regulations and standards. If there are standards out there for your particular machine, a power press, a robot, a palletizer, a case packer, there are certain standards that apply for your machine. So in most cases, if you're following those requirements, even though in the United States ANSI standards, NFPA standards, or consensus standards, these are very good standards put together by subject experts in those particular fields. So they are very, very good. If there are no standards, then it is imperative is to do a full-blown risk assessment for your particular machine. Comply with applicable regulations and standards is the first step in the risk assessment. I did want to make clear that, and you're all probably aware of this, and I apologize for being redundant, is that OSHA is for the end user. If you are a supplier, if you are a manufacturer, you need to be looking and assessing the standards for design performance, ANSI standards, UL standards, NFPA standards, NEMA standards, in the design and the assembly of that particular piece of equipment. So you have two different issues that are going on. The regulations are the OSHAs, those are the law. Other, the ANSI standards, which are good performance standards that are written by subject experts, are ones that the suppliers, the manufacturers should be following. Okay. Inspect. Closely inspect the machine for non-compliance issues. Can I reach over? Can I reach around it? can I get into the hazard and get myself hurt, whether inadvertently or intentionally? This is very important because people have a tendency to say, well, inadvertently, I can't get into it. But if I wanted to, I could. And people, as you know, maybe in your experience, people have gotten hurt, not because they wanted to, but they're trying to do a good job and they're reaching over a machine or under a machine to take out a jam or make an adjustment while the machine's running. So very important is to look at inadvertent and intentional access into the machine. And again, we're talking about standing on the floor, not on the ladder or climbing over the guarding system. The effectiveness of the protective devices. We talked about openings and guards. Safe distance requirements. Where do I put my light curtain in relationship to safely stopping the machine before either my hands or fingers or my full body access gets into a hazardous zone? Emergency stop availability. Required safety circuitry integrity for the control. The higher the risk, the higher the safety circuitry integrity that must be on that machine when you're looking at interlocking systems. Observe. Watch all the phases of operation. Normally, when I'm out on a particular project, I will videotape the equipment. But sometimes still pictures are okay, but videotaping and seeing how the process works and also seeing how people interact with the machine is extremely important in helping giving you guidance in your risk assessment. Production run, look at minor servicing, adjustments, unjamming, minor cleaning, major cleaning, preventative maintenance, troubleshooting. A lot of times troubleshooting is extremely a very, I want to say, dangerous situation because a lot of times fixed guards are removed, interlocks are bypassed, because in some cases, that particular test cannot be performed with guards in place and interlock doors actuated. So again, these are very important phases in the operation of that particular piece of equipment. Interview. Talk to personnel keeping the machine running. Talk to the operator. You know, how often do you have to load the cardboard into the Douglas case packer? How often do you do that? When you do that, how long does it take you to do that? Same way with maintenance. If you're doing things from the standpoint that lockout, tagout, that's very important. Then you know that in how they do that. Is there a procedure for that? Yes. And you explain to me what that procedure is, not only getting it to zero energy state, but how do you turn the machine back over and put it back into production? What are the steps involved to safely do that particular process? Interview the factory safety personnel. What incidents, what near misses do we have? What's the history on this particular machine? Are there work instructions? Are there SOPs that we need to put together? Do we review these on an annual basis or on a routine basis? The objective is to identify all risk sources. Intended use, and again, the other flip of the coin is the possible misuse of the equipment. Very important factors. Review, analyze current safety status. Have all the hazards been identified? Are all the hazards controlled? Review the pertinent instructions. LOTO, JSA, job safety analysis, some will call it as hazard safety analysis, work instructions, SOPs. Do we have these? Are they in place? Are they being followed? Are we reviewing them? Are they being updated? These are very important documentations. Estimate. Work through the risk assessment worksheet that you have. There are various good risk assessment matrix out there. Different companies use different ones. But again, easy to use, easy to follow, easy to understand, and easy to share. And they're standardized from plant to plant within that organization. Estimate the risk, evaluate the risk level, provide risk reduction recommendations. What is a risk estimation? Measure the risk exposure using tools to eliminate three factors. We talked about this before. Potential severity. What's the degree of harm? Am I going to just cut my finger? Am I going to get myself stitches? Am I going to lose part of my finger? Or do I buy the farm? Probability of the injury. Is it easy? Is that hazard right there under my hand in the production operation? Or is it up and over, it's very difficult to get to, but I can get to that. So the probability of injury, the frequency of exposure, how often is someone in that particular area that is exposed can get to that hazard. Remember, we're looking at this as not only the inadvertent contact, but intentionally getting in. In a lot of cases, these are on in-feed and out-feed areas where product is going into the machine to be processed, and it comes back out the other end where I've got big openings where someone can reach through to put a product back on a conveyor belt or remove a jam without going through an interlock door. So again, taking those into consideration, those two important factors of inadvertent contact and intentional contact. Remember, people generally don't get up in the morning and say, I think I want to hurt myself. They're out in the plant wanting to do a good job, and sometimes their motivation is to try to circumvent the system and keep production going. So that's very important in your guarding system to complement the production and the efficiency of the machine. How do I know I reached acceptable risk? Well, apply the risk reduction measures from applicable standards. Got the standards, I follow the standards, I should be in pretty good shape. Compare best practices in similar industries. Now, I don't think you will find a standard particularly for e-stops. Normally you'll go to 70, go to ANSI, you'll go to NFPA 79. But in Europe, there is a particular standard. It's a EN, I believe it's 13850, which only addresses e-stops, design, application, location. So that's a good best practice, though it's not a standard in the United States. It's a good resource. It's a good best practice. Select and apply a risk assessment methodology that provides guidance in risk reduction. The methodology should be a relationship between risk level, exposure, and risk reduction. Methodology should be a proven, viable process. If you go to B11.0, that's a very, very good document to put together your risk assessment process if you're looking for one. If you have one in place and it's working great, that's fine. You may have to look at that and review it and see if it needs to be tweaked. Validate the safeguarding design and application. Monitor the effectiveness over time. One thing, if you have 6 machines, they're all identical, and they all have the same risk exposure, my suggestion would be to do one machine, do your assessment, apply the safeguarding measures for the risk reduction, make sure everybody on your committee is buying into that design, maintenance, operation, quality, engineering, and safety. And if everybody's signing off and everybody's comfortable with it, they can do the job and keep them safe, then you can validate that and then basically cut that guarding system and do the other 5 machines. Okay, the hierarchy of safety engineering and review, we talked about this before, is to elimination, substitution, engineering controls. These are very, very important from the standpoint that engineering controls and substitution elimination, I don't have to concern myself that much with how much training or how much skill level, how much knowledge that they have to prevent being injured. It's in the engineering control aspect. Once I drop over that line and get into areas of awareness, means basically warnings, administrative controls, writing SOPs, writing work instructions, and PPE, that falls more into the behavior safety and more into the administrative controls, which sometimes, in some cases, is somewhat difficult to control. But your engineering controls, if I don't have the education, I come off this, I don't get the training that the other person got, when I open up that interlock door, it should stop. Whether I've had training or not, the engineering control covers that particular application. It's like your microwave. Put something in the microwave, the bell goes off. How many times does somebody open up the door and not hit the stop button? Especially when you got a 4 or 5-year-old putting muffins in the microwave. You know, when the bell goes up, they just open up the door. That's why it's interlocked for that particular application. Okay. And at the end of the standpoint, and I leave this with you, is to err is human. We know that. But to forgive is by design. Thank you very much for your participation and your attention to the presentation. Thank you.
All right, thank you, Doug. A few of you have already submitted questions. If you have not already, please feel free to submit questions during the Q&A session. You should have a window on the left side of your screen. So we'll go ahead and get started here. Does the SOP stand for Safe Operating Procedures?
Oh, it stands for Standard Operating Procedures. One thing I wanted to expand on that, and it was a good question, is that work instructions and SOPs are basically your big, what I want to say, your safety program from the standpoint, lockout tagout program, or SOP, typically is 6 or 7 pages. It involves your scope, your definitions, your training, the devices you're using for lockout tagout. Work instructions are one-pager. They're a step-by-step process. When you buy a product or you buy a barbecue grill, it's got work instruction there. Do step 1, step 2, step 3, step 4. That is a work instruction. And normally what I do, my philosophy is, in a work instruction, maybe this is heresy, that I never use the word safety in my work instruction. What I do is at first, and I make them very short steps, and in 1, 2, 3, is I start every sentence with an action word. But I never use the word safety in the work instruction. If you do step 1, step 2, step 3, there's 10 steps, and if you do those in order and follow those intuitively, you're going to be doing it the most productive way, the most efficient way, and the safest way without even inferring that it is the safe way. So that's my philosophy in doing work instructions, is that I never put the word safety in. I will tell you in lockout tagout, make sure you have all your tools ready to start, make sure you follow your lockout tagout procedure, but I've never said the word safety. It's part of the work instruction, to do that particular job. So I just want to share that with you because I found it to be most effective when sharing this with other functions within a company.
Okay. What's the difference between risk assessment and FMEA? Oh,
you're talking about FEMA's? FMMEA? That's
yes.
Analysis, effect analysis. Well, that is one where, again, if something happens, okay, what's going to be the effect of it? Normally, FEMAs are done in chemical plants and they're done in the aviation. If you're 36,000 feet and you lose the hydraulic pump on your landing gear, you're in big trouble. So it's more detailed. It's more in depth. There's you can use a FEMA for a machine, but I think it's I want to say it's an overkill. I don't think you have to go that far from the standpoint, but FEMAs are a risk assessment, but more of the higher severity of, particularly from the standpoint of designing aircraft in the aviation industry.
Okay, let's see here. You talked about protection from physical hazards. What about the hazards from exposure to chemicals coming from the machines? Do you do the risk assessment at the same time?
Yes, you do. You want to look at all your energy sources, all the hazards that one can be exposed to in the design, whether it's in your chemicals, whether you're hard piping those or you have them in a particular flexible hose. Are you using the right type of hose for that particular chemical? The pressures, are the hoses meeting the pressures that are intended for the process? So yes, you do want to look at steam, chemicals, springs, mechanical, electrical. These are all very important aspects and ingredients that you need and hazards that you have to address in that particular machine and process.
Okay. Regarding polycarbonate shielding, observation windows in machine enclosures, many of the machines at my employer's location recommend a 2-year replacement frequency. Are you aware of any available industry test data for the specific types of machinery?
Are you talking for the Lexan, the polycarbonate? There is a particular standard, it's an ANSI standard dealing with glazing material. Top of my head, I can't think of it right off the top, but I'd be more than happy to pass that on. One thing, though, when we were talking about the Lexan, when you are putting Lexan or expanded metal, the application, I strongly recommend that if you are putting this material, using this material, to use this material, if you are protecting and fixed guards over belt and pulleys and over chain and cog drives, because I can shut the machine off, I can check the belts and see if there's any freighting being created by the belts without having to lock out the machine and take a full solid guard, metal guard, off the belt and pulley. Two things. One, you're still providing that protection, but the other aspect of it is efficiency and safety. I don't have to remove the guard to do a visual inspection performed by the maintenance, whether it's Lexan. Normally in Lexan, they don't like to use the Lexan because of the chipping, particularly in the food industry, but the expanded metal provides the protection, provides ventilation for the belts, keeps the belts relatively cool versus enclosing at the heat, but also I can turn the machine off and still do my inspections without having to lock out the machine and take the guards off. So Lexan is good. I don't, like I said, there is a glazing standard, it's an ANSI standard, and off the top of my head, I can't remember what that is, but there is a standard for the Lexan they use. And one other thing, too, is when you use Lexan, it's very important that you use cleaner that is compatible to Lexan. Don't go out and start spraying it with Windex, because about the second time it will frost, and the benefit of having Lexan to see through it will be gone. So make sure if you have Lexan, you use the proper cleaner that's compatible with Lexan.
Regarding the economics of practicable risk reduction measures, do you have a recommendation as to what is considered cost prohibitive? What is the threshold?
Well, that has to be decided inside. It's on a case-by-case basis. Let me put it this way to you. Let's say that if in my plant I have, let's say I got 90 dBA in my plant. Now, I got a large plant. Let's say for $100,000, I can engineer out the noise to below 85 or maybe down to 80 dBA. Now, I've got to take into consideration, I got 100,000. In most cases, they like to see a payback, on that within a year, a return on investment. But I've got to look at the cost involved with hearing protection. What am I paying for that over, say, a 5 or 10 year period? What's it costing me to police this? What is it costing me for audiometric testing? What's all these other incidental costs that deal with me having to wear hearing protection? That $100,000 may pay for it. Now I have one less hazard that I have to apply PPE. Now, if it's going to cost me over $2 million to put an engineering application, that may be cost prohibitive, and I may have to rely on administrative controls and PPE.
Where's the best place to find a template for a risk assessment template?
What I would do is, if you have access or have a copy of the B11.0, that's the risk assessment standard for U.S. If you're in Europe, the ISO EN 12100 is the risk assessment document for Europe.
How can we make sure that the team is competent enough to consider all the aspects related to a machine or process risks? Do we need to involve special expertise for specific risks? How should we define the competencies of the risk assessment team?
I think that those individuals need to have the proper training in the process, so everyone understands their role and in the application. And again, to recognize hazards, you speak with people that go out on the floor and you start pointing things out to people, and in most cases they don't realize that that is a hazard until after the fact someone gets hurt. So I would say a third party like PILS to be able to come out and put on training so people understand, and then put together the training would be involved working on the floor to actually getting people involved in assessing a machine and then evaluating that in a classroom aspect to give them some confidence and a comfort zone to be able to go forward and do risk assessments. I think the training, getting everybody up to speed is very, very important. Again, from the standpoint of getting the right parties together, but the training by third-party experts, I think that would be the better way to go.
Okay. Do you know of any generic software you can use to aid in risk assessment? There are some out there. We at PILS have our own tool. There is, again, if you go to the B11.0 standard, there's the HRN application, which is the hazard risk number application. That is very good. You do have, I've worked with a lot of international companies that have designed their own type of risk matrix. They're very good. But again, I would refer back to those in the United States is looking at getting a copy of the ANSI B11.0. It's the risk assessment document, and it will give you some very, very good guidance and information in putting together a risk assessment matrix. How does NRTL come into play with risk assessment? If I have a robot certified to UL 1740, do I need to get a risk assessment?
It would be important to do a risk assessment, because if it's a standalone, it's one thing, but what is the hazards? What is the environment? Are you? What is the robot going to be doing? What is it going to be picking up? What is the distances? Am I going to have? Can I use light curtains? Or if I have a part that's on the end of the grabber, it can come loose. Light curtains will not stop that projectile. Well, now I have to put up fencing versus putting up light curtains. Yes, I would say where and what products you're going to be using, speeds, risk assessment would be a very good way of making a determination as to what else I need to complement the safety in working around that robot.
What is the requirement for having anti-restart devices?
I'm thinking the question, the restart devices, they're designed, the NFPA 79 says that the machine, if you have a storm, you have a bad thunderstorm, and you have a blackout or a brownout and the machine shuts off. When the power comes on, the standard says that machine cannot start up automatically. You have to go through the process of starting the machine the way you would do if you were coming in off a weekend and starting the machine up on Monday, is that it does not, power goes out, power comes on, the machine shall not start back up without some type of process of a process of starting the machine back on. It does not come on automatically.
Let's see here. If you have any questions right now, please feel free to type them into the box on the left-hand side of your console. Our next question, to what extent do you assume the operator will follow proper procedures when doing a risk assessment?
I have found in my experience is if I have an operator on a particular machine that I have confidence in that they will be forward, provide information, positive constructive type comments, and they're working on that machine and they're part of the committee to get their say, their input, and things that affect them in the production, and they're part of the risk committee, there's a high degree of probability that they will follow whatever comes out of their risk assessment because they've been part of the committee, they have a say. Not always are they going to agree, but if you have a consensus, at least you listen to the operator, you took that information, how can we implement that into the design so we can provide a reasonably safe condition and still allow that operator to do their intended task. Whether, again, from the standpoint, you're more or less looking at an interlock type guard, an ergonomic application also, versus a fixed guard, which is normally that would affect maintenance, the weight of it, how many bolts are in it, are they captive bolts, things of that sort. But talking about the operator, okay, we've got to put together an interlock door, first of all, because we knew we got frequency. But getting an operator that knows that machine, have them on that committee to participate in the risk assessment, and there's a high degree of foreseeability that participation and listening to that individual, getting their input, enhances that person will follow the procedures because they know the machine and they've got their input into it. Buying off on that machine, I think that's a high degree of foreseeability that they will follow procedures and not try to circumvent or bypass the safety systems.
During a risk assessment, which score is affected by the identified control, the hazard score or the severity score?
They're all combinations. If you look at a risk assessment, we talked about the three factors. We talked about the frequency, the probability, and the severity. And there's numbers in there that you can look at from the standpoint that, let's say, I'm exposed to an amputation hazard once a year. That the probability of avoiding that it's somewhat difficult to get to. But again, I'm losing my finger. So based on a frequency, it's only once a year, and it's difficult to get to. But if I do, it's right there, this open chain, say on a chain conveyor, on a palletizer on the end, if I could lose my finger. So again, that still could be considered a high risk based on the severity, even though the frequency is once a year I may be down in this particular area. So again, there's a combination of those three factors, and if you put it into a numerical application as the HRN, it will give you what you have and make a determination. Do I accept that risk if it's low risk, or do I go after my hot items, my items that are very, very high risk?
Okay, our next question. Do you have any format or document that we can use to know easily the severity, probability, and frequency of any hazard?
All I can say that we do, that we use here within PILS, I can't share that with you, only if you want us to come out and do the risk assessment. But again, in the B11.0, there are those indicators in there to help you with the risk matrix. There are other, I'm trying to think, some other data out there. Again, the EN 12100 risk assessment gives you some applications from the standpoint of giving you a numerical evaluation of those severities, the probabilities, and the frequency of those areas. So again, I can reference you to the standards. PILS has a particular risk assessment application that we use when we work with our customers. And at that particular time, we share that with the customers when we perform the risk assessment. But I would imagine there are others out there that can be utilized.
Okay. How do I know that a risk level that I have is okay? Is there any standard for values for low risk, medium risk, and high risk?
Well, if you go through the matrix that is established in the B11, when you get to a low risk, that has to, and compared to, say, a medium or high risk, you want to, look at your assessment and set priorities. I want to get rid of my very high, my high risk, my medium risk. But when it gets down to the low risk, senior management has to decide: are we going to accept that, or is it, even if it's a low risk, it's going to cost me $75 or $100 to put a fixed guard with 4 bolts in it? I may say, let's just go ahead and spend the $100, even though it's a low risk. But the determination of doing a risk assessment, the risk assessment committee needs to put this together, come up with those values, and then present those to senior management. Their job is to do the risk assessment, set up what those risk levels are, and to present them to senior management, and then work with senior management. What are we going to take? Where are we going to set our priorities? Because there's not going to be enough money, enough time to do all of them. So you want to set priorities in your risk assessment. Which one do I need to address first? So taking priorities rather than going after the shotgun effect, set your priorities. So again, you need to look at risk matrices that are out there, and again, take into consideration which one you want to use, which one's easy to understand, which one's easy to share with other people, and being able to set priorities.
All right. We have time for a couple more questions here. In a risk assessment, do you assume that the machine will operate properly, or do you need to allow for things that may break, therefore creating a hazard that previously wasn't there?
Being from working both sides of the fence, being an OEM, a supplier, and an end user, a new piece of equipment, I would still, before I commission the machine that's coming out, to be fair to both sides, as an end user, I would do a risk assessment on the machine. Because what I have found, not always, but what I have found, that a machine has exposures that may not have been addressed, particularly from the standpoint that we talked about inadvertent contact versus intentional contact. So I would, as an end user, my suggestion would be, you're buying a piece of equipment, before it gets to your plant, I'd have my risk team together, trained, and have someone or that team go to that particular facility and look at the machine and doing a risk assessment. And if there's anything that needs to be done, it can be done right there at the manufacturer supplier before it gets to your plant, because when it gets to your plant, production wants to put it into production. They want to start making products. So I would not assume. I would have someone that would commission it, more so from the standpoint of accepting that at the supplier or the manufacturer's, the OEM's facility. That would be my suggestion. Maybe it doesn't always occur that way, but I would not assume that it is safe to run, operate, to maintain, whether it's a guarding, whether it's ergonomics. I want to look at everything. So I would not take it for face value. I'd want to have my committee do a risk assessment on it, whether it's a new machine or machine moving from one plant to another.
Okay, well, it looks like we've run out of time. If we did not get to your question, everything will be passed along to Doug. On behalf of EHS Today, I would like to thank Doug for his presentation and discussion, as well as Pills for making this webcast possible. I would also like to thank you, our audience, for your time and attention. We hope you found today's webcast valuable, and we will return for future EHS Today webcasts. Have a great remainder of the day.